The growth of the population and level of life in the cities implies an impressive increase in the demand for services and goods being concentrated in urban areas. Globalization of the logistics scheme with the recent advancement of telecommunication and e-commerce enables the fact that many companies shift to the on-demand economy, where the product or services become available after the client positions the order. Due to this, the number of parcels moving around the city increased exponentially, and the time windows for the good delivery becomes relatively small, up to 2 hours in an urban area. Also, the COVID-19 pandemic of the recent years worsened this situation. In such circumstances, the transportation of goods around the city significantly impacts the final product or service cost and yields the problem of the urban infrastructure overloading and the following delivery delays. These issues impact the whole existing logistics scheme, causing it not effective anymore. Moreover, it follows with a significant increase of CO2 emissions, considering the transportation industry have been identified as one of the biggest causes of global warming. Hence, well-organized delivery becomes a crucial part of successful management strategy for each company on the market. To this end, we can observe increased usage of the third-party logistic providers, represented by the companies dealing specifically with the operational part of the logistics. However, the demand for the logistics services remains a subject being highly impacted by uncertainty. In these conditions, the decision-making process on the tactical planning level about the fleet quantity and type becomes a non-trivial task and a requirement for the successful resource management for each company. In the literature, this process is known under the definition of tactical capacity planning and was covered by different stochastic programming applications based on the bin packing problem mathematical formulation. Meanwhile, this approach is able to hedge against uncertainty. It's missing the ability to deal with a large-scale realistic problem instances in a reasonable time. The solution of this issue is the application of machine learning algorithms to the highlighted problem, which becomes reasonable with the presence of big data sources and vehicle tracking systems. Our work is to introduce the newly designed decision support system that combines the achievements of the machine learning algorithms in uncertainty treatment and stochastic programming for the optimal solution. Such a system is able to work in realistic scenarios and aim to support a managerial decision on the tactical capacity planning problem, which for years was mostly empirical. Firstly, we take care of the vehicle type diversity, since the optimal setup for the urban delivery frequently includes not only vans, but the electric small vehicles and bicycles, depending on the infrastructure development and regulations. Bike delivery is a very promising step towards reducing CO2 emissions. Then we introduce the spatial demand correlation analysis by the different regression support algorithms. We identified the best setup in which the system is able to predict the demand based on the real data collected in the city of Antwerp, Belgium. Finally, we substitute the heavy parts of the stochastic programming algorithms related to uncertainty with the machine learning approaches. In this way, the optimization part remains deterministic, and we are able to deal with a large set of instances in the reasonable time. Moreover, the proposed solution is able to solve the problem up to 13 times faster, which gives us the possibility to use it in the online setting. As a consequence, such a decision support system can heavily impact the resource allocation optimization for any company, saving not only transportation costs but also reducing environmental pollution.